All right. Hello, Integrated Math 2 Advanced. We're going to look at the lesson 3 notes, and it's pretty short, guys. It's just 2 pages. So I think I'm just going to make one video, post it, and you can go through these. And once you understand these, you can look at the homework. But I don't think this is going to be too bad of content, especially if the first 2 lessons were okay. All right, so as a review of what we looked at before, right? We talked about the length of a line segment. This is also the same thing as the distance formula. Right, so this is the same thing as the distance formula. If we have points x1, y1, and x2, y2. And then we talked about the midpoint of a line segment. So find the midpoint of 2 points. And then I believe we talked about slope, right? This is known as rise over run. And so we take the change in the y values. One way to do that is y2 minus y1 over the change in the x values. Okay, these are from the last classes. This means parallel, right? So if these 2 lines are parallel, the only way that can happen is if their slopes are equal. And then in a similar way, if 2 lines are perpendicular, their slopes, when you multiply them together, their product has to be -1. Okay, so I'll just write this notation. This means parallel. And then this means perpendicular. Sometimes perpendicular. Sometimes you'll hear the language orthogonal. It's the same thing. Okay, so we've got 3 forms of lines. You guys have to know all of them, okay? This is slope-intercept form, right? The reason we call that is M is the slope and B is the y-intercept, right? So B, this is the y-intercept. Then we have standard form, AX plus BY plus C. I actually prefer to make those capital letters, okay? And the thing here is that A, B, and C have to be real numbers. Real numbers. Actually, you know what? Guys, I'm having a brain cramp right here. I think, let me go back real quick. I think they actually need to be integers. Yeah, I'm gonna say that. Okay, so pretend you didn't hear me say they need to be real numbers. These need to be integers. Integers. Okay, and I would argue this point slope form, slope point. I don't know if that's correct or if we made a typo, but I've always learned it as point slope form. Okay, this is really useful, guys, because we need 2 things. We need 1 point, any point on the line, right? And we can call that point x1, y1, okay? And then we need the slope. This is really, really, really useful, okay? So you can, if you want, use your y-intercept, and you can say that that's the point 0b, and you can use that here, okay? Don't have to. So, typical question, right? Can we find an equation of a line given certain properties, okay? And the way I want you guys to think, right, is for any line, we can write the equation of any line if we have 2 things. We need the slope and we need a point, okay? That's it. Now, right here, we've got 2 points, so I'm just gonna use the first one. Okay, so I'm gonna say that the point that I have, or that we have, is 3, 8. The slope we need to compute, okay? So I'm gonna do, I'm gonna start with point A. I'm gonna use these values first. I'm gonna do 8 minus -3 over 3 minus 2, okay? So the slope we have to compute, that's 8 minus negative 3 over 3 minus 2, and that's 11, because it's 11 over 1. Okay, now, because I have that, I'm going to use point slope, right? That's the beauty of point slope, is you can write anything in point slope form if you have those two things. So we're going to go y minus 8 equals 1 times x minus 3. Okay, again, so the 0.38, right, I'm filling that in. 3/8's going in. This is 3, this is 8. Okay, so here's my x value, 3. Here's my y value of this specific point. And the slope goes in right here. Okay, so super useful and easy. Super versatile too. Okay, next I'm going to convert that to slope-intercept form. Okay, so slope-intercept form. Okay, and that's mx plus b, right? Y equals mx plus b. So we've got to do a couple of things. We have to distribute this 1 through, but really we've already got that. So it's x minus 3. We need to move this over. We need the y isolated. So I'm going to rewrite this as y equals x minus 3 plus 8, right? So I'm just taking this minus 8, I'm adding it to both sides. So it cancels on the left, right? And then this 8 goes over as plus 8. And now we just add these together. So that means that y is equal to x plus 5. Done. Okay? So there are our first two forms. And then if we want to put it in standard form, well, what's standard form? Okay, standard form says, put it like this, put the x term first, put the y term second, and then put the constant by itself on the right side. So basically what I gotta do is move this x over, okay? So the standard form is gonna be negative x plus y equals 5, okay? And all I did is I took this and I subtracted x. Okay, that might be maybe more confusing the way I did it, but I basically just subtracted x from both sides. And then the convention for standard form is you have the x term first, the y term second, and then the constant term on the right. Okay, easy. Let's just check. Did we get the same thing a couple years ago? Y minus 8 equals 11 times x minus 3. Oh, yes, I'm glad I caught this, guys. You guys probably caught this too. Okay, my slope, I computed it correctly, but I didn't write it correctly. Oh, man. So that's going to be an 11. That means that this was an 11. This was an 11. And then when I move it over, it's going to be a negative 11. So I'm really glad I checked. Okay. Let's just clean this up too. So this was 11x. Okay, good. Really just one more page of examples that we'll do together. And then that's it for today. So, you know, there are going to be some harder questions where they don't give us information directly, okay? But we still want to just always think, what's the slope of the line we want? And what's a point on the line we want? And then if we have those two things, we can write the equation of any line. Okay, so now we have, it's parallel to this. And then it passes through this point. So the point, I'm going to start with that first. That's negative 3, 3. And now the slope, well, if it's parallel, right? If it's parallel to this, it has the same slope of this. And the slope of this thing, if we rewrite it, it's going to be 3y is equal to negative 2x plus 5. And so I know I'm going to have to divide the 3 over to get the slope. So I know basically the slope is negative 2 over 3. And that's going to be the slope here. Hopefully that makes sense. Okay, so again, I'm going to start with point slope because we have a point and the slope. Point slope. Let me erase this. And then after that, we can convert to the other two forms. Probably should have just. Okay, so point slope is going to be y minus 3. Remember, point slope says y minus whatever your y coordinate is. That's the start, equals the slope. Well, the slope here is negative 2/3 x plus 3, right? Because we have x minus the x coordinate, x minus negative 3 is plus 3. Okay, done. Let's just check, right? Just check. Y minus 3 equals negative 2/3 x plus 3. Yeah. All right, now we'll go to slope intercept, right? So we'll do slope int, which again is y equals mx plus b. So again, what we're going to do is distribute the negative 2/3 through and then add the 3. So this is going to turn into y equals negative 2/3 x plus, that's going to be negative 2, right? Because negative 2/3 times 3/1, the 3's cancel, we get negative 2. So actually, plus negative 2 is kind of ugly notation, so I'm just going to write it as minus 2. And then I've got to move the 3 over. So we have a plus 3, right? That's this minus 3 getting moved over. So these turn into just 1. So we get y equals negative 2/3 x plus 1. Okay, finally, standard form. So that's going to be, so now what we want to do is have everything with integers. So I'm going to take this original equation that we had here. I'm going to multiply everything, every term by 3. So this by 3, this by 3, this by 3, just to clear that 3 in the denominator. So 3 times y is 3y. Okay, and then 3 times negative 2/3x is negative 2x. And then finally, 3 times 1 is 3. Okay, so what I did with this, right, guys, was I multiplied everything by 3, both sides. And now we're almost there. We just have to move this over. So I'm going to move that over and write it as 2x plus 3y equals 3. Done. Let's just check that. Yep, same as last time I wrote these. Okay. So now we have to draw the graph of the line below and label it with your favorite equation. Okay, so it goes through negative 3, 3. 1, 2, 3, 1, 2, 3. So there's the point Q. Oops, I don't know why I did that. That's negative 3, 3. And that's point Q. And then it has a slope of negative 2/3. So we go down 2/3. So, okay, here's our y-intercept. And that should be 1 graphically. And it matches the 1 here. Okay? So I'll label that point 2. That's 0, 1. And then, this is just going to do this a couple more times. So down 2/3, down 2/3. I try and make this as straight as I can, guys. 1, 2, 3, and then it's gonna go sort of like this. Leave a little space for that. Okay, so there's our line. And I'm gonna write this in point slope. So this is y minus 3 equals negative 2/3 x plus 3. Okay. So now maybe you guys try this, right? Or if you don't want to, well, I'll go over it. The only change, right? We've got to write another 3 equational lines, but now we have a line that's perpendicular to this line, and that passes through the point. Okay, so if it's perpendicular, remember this means the slope, a negative reciprocal slope. So here's our slope. That means the slope of the new line, the perpendicular line, is going to be positive 3/2. We flipped a number and we changed the sign. And then our point is 1, negative 1. So we can go y plus 1 equals 3/2 x minus 1. Where is that coming from again? Well, it's y minus the y coordinate, right? So y minus negative 1 is plus 1 equals m. That's the slope that we found, times, in parentheses, x minus the x coordinate of our point. Okay. So now this is the same thing as y equals 3/2x minus 3/2 minus 1, so that's minus 5/2. Okay, all I did there is distribute this. So 3/2 times x is this. 3/2 times negative 1 is negative 3/2. Minus 2/2 is negative 5/2. And then lastly, let's multiply everything by 2 and move the 3x over. So if I do that in one step, which is probably not a good idea, but I'm going to do it, we get, see, it's messed up with the first number. We get negative 3x plus 2y equals negative 5. Okay, so what did I do? So all these terms get multiplied by 2. So y becomes 2y, this becomes 3x, and this becomes negative 5. And then I just move this over. And then lastly, we have horizontal and vertical lines. We looked at this last time, I think, with the letters. Remember, a horizontal line has a slope of 0. A vertical line has a slope undefined. So basically, we just write them as their x or y coordinates, right? If a horizontal line goes through the point 5, 3, then we can just say, well, because there's no rise, the slope is 0, so it's just always the y coordinate. So any horizontal line is going to be y equals some number. And any vertical line, you could probably guess, a vertical line is going to be x equals some number, okay? So if this thing has no run, right, it just keeps going up and down, then that means that x is negative 2 is the equation of our line. Okay, so there we go, guys. The new stuff is, maybe not new, but new for this class, is learning these 3 equations of lines and just getting comfortable writing lines based on information. And really, if you guys can think, and this goes all the way up to calculus class when you find the slope a different way, if you can just remember, okay, to write the equation of any line, right, I need 2 things. I need a slope and a point. Then you can be really, really good at writing equations of lines. All right, hope this was helpful. I will see you guys soon.